It's the last video for Unit 8 Quadrilateral Exam Review, dealing purely with trapezoids, first two being isosceles trapezoids, and then 19 and 20 being the trapezoid, specifically talking about the mid-segment theorem. Question number 17, though, isosceles trapezoid. Properties we know about an isosceles trapezoid is that the non-parallel sides are congruent. And additionally, the lower base angles, so this would be angle A and angle D, are congruent. And we also know that the upper base angles, so that would be angle B and angle C, are also going to be congruent. We'll start there to go ahead and solve for y. Since the upper base angles are congruent, we know that 7y plus 2 should be equal to 100. Solving this two-step equation, 7y equals 98, or y is equal to 14. The lower base angles are also going to be congruent, meaning that 4x plus 12 is equal to z. Now we have a problem here. We need to figure out either the value of z or the value of x first, help us solve for the other value. That leads us to the last property of isosceles trapezoids, which will be useful here, is that any upper and lower base angle are supplementary. So that means that either A added to B is 180 degrees, or C added to D equals 180 degrees. So then we'll go ahead and focus on this relationship between angle C and angle D, meaning that 100 plus Z should equal 180 degrees, meaning that Z is equal to 80 degrees. Substituting this value in means we have the two-step equation 4x plus 12 equals 80. Solving this two-step equation gives us 4x, giving us x is equal to 17. Okay, question number 18 on isosceles trapezoid. Properties that we know. Once again, we know the fact that non-parallel sides are congruent, which will help us solve for letter Z. Giving us the equation 2z minus 8 is equal to 40. Solving this two-step equation gives us that z is equal to 24. Additionally, we know from an isosceles trapezoid that the diagonals are in fact congruent, meaning that each piece of the diagonal is congruent as well. So this piece EC is congruent to this piece BE, and this piece AE is in fact congruent to this piece ED, which sets up the equations y minus 6 equals 12 and 5x minus 16 equals 19. Again, from our pieces being equal, solving these multi-step equations gives us y is equal to 18 and x is equal to 7. Okay, questions 19 and 20 are very similar. We are given a trapezoid and we are given this random-looking diagram. E and F are the mid-segments of AC and DB respectively, meaning that we have a formula for the mid-segment. Mid-segment is equal to base 1 plus base 2 divided by 2. So I would add up the two bases. We can call this base 1 and this base 2, divided by 2, and that should be equal to our mid-segment. Substituting in these values into the form gives us that the mid-segment, 9x minus 7, should be equal to this 16 plus 42 divided by 2, or that 9x minus 7 equals 29. Solving this two-step equation gives us that x is equal to 4. Number 20, we have a very similar scenario to number 19, so we will once again know this is a mid-segment problem and start with the formula that the mid-segment is equal to base 1 plus base 2 divided by 2. Substituting in our value gives us that the mid-segment, 5x minus 31, equals base 1, 36, plus base 2, 42, all divided by 2. Simplifying this down gives us 5x minus 31 equals 39. Solving this two-step equation, 5x equals 70, or x is equal to 14. Whole back page devoted to trapezoids, mid-segment being the biggest, most tested SOL topic. Also using the properties of an isosceles trapezoid to help us find missing values.